forward to speaking with as many of you as possible in those breakouts later today. As you mentioned, my name is Michael Gregory. I am Field CTO lead for data science and machine learning at Snowflake, based in our Amsterdam office. And in my role, I really work with a lot of our customers and organizations, helping build out their data science and machine learning capabilities and building around, centered around cloud native technologies. And very glad to talk to you today. I think, the things I have to talk about today are in some ways a cautionary tale, but I do think it starts by maybe taking a minute to explain what I mean by back to the business. And that might be a little bit unsure for some people. I guess we start the topic today by saying, we often hear stats like 90% of AI projects fail or X% of models never make it into production, et cetera. And I'm sorry to say, but this is just the nature of science. If it was the deterministic world that we lived in, we wouldn't call it data science, right? In a stochastic world, ML models fail millions of times per second. Obviously, I really like what Justina was saying earlier today about creating an environment where this can happen, but also it's just the nature of what we're building. A failure is a certainty, but hopefully, failing along the right direction of the gradient in this case. Or, maybe a different view is like George Bach said, all models are wrong, but some are useful, right? As we know, these statistics about enterprise success rates, et cetera, they're really, a little bit inflammatory and often usually designed to sell enterprise software or analyst service. Perhaps the more valuable conversation is to look at how or if organizations are building scale and efficiency around what they're building. Many, maybe most of the organizations out there today they're building momentum and starting to build really great successes. We heard some comments on the panel just a minute ago about kind of where people are in their journey and what they're developing. And if you have gotten to the point where they're really building economies of scale in the AI and ML as well, and the promising news is, of course, that breaking through that glass ceiling, they are consistently seeing great return on investment, right? And so, what is it about these companies? What have they been able to do that others can't, or what's the magic? I guess I'll give you a hint. Of course, it's not because they have more money to spend on AI and ML, or it's not because they can somehow attract the right talent for their teams, although that's also important. Many of them have crossed the chasm just by focusing on the right problems, pulling on the right threads and optimizing the right things. Those threads are a bit different for each organization in the industries that they're in, but you can often put them into three kind of big buckets if you kind of, go up to a slightly higher level view on that. Of these three, I'm going to speak today mostly about the last one and the nature of islands that have been created and the need to tear down those barriers and bridge the gaps. Looking at the first one, though, building a solid data foundation, it's really about recognizing that the ML models are just the tip of the iceberg. I've heard many comments on the panel just a minute ago recognizing this. I think we all kind of know this. A lot of this kind of goes back to this 2001 paper by Leo Breiman, right? Who extols the virtues of what would today ironically be called, the model-centric AI, which has really led to much of the incredible advances we've seen in algorithms and techniques, right? But fast forward to 2021, the nature of applying these techniques outside of purely academic endeavors really requires doubling down on the data itself. This is the Andrew Ng world of data-centric AI as an example, right? And in my conversations with organizations, this philosophical difference is perhaps the most stark difference that I see between those that scale and those that don't. A recognition that building a good data foundation empowers the data-centric AI world, which is, of course, the foundation for making success going forward. It's recognizing that a lot of the hard things to do in building AI are not just the models itself. As we take a look at other bottlenecks, right, specifically computing as well, when your teams are preparing data or descending gradients or calculating predictions, there are just a certain X amount of compute that's needed. You can spend lots of time trying to get that to X minus 2% algorithmically, for instance, or maybe negotiating 1% reduction in contracted pricing or moving data around between your various infrastructure in order to find the most optimal place for it. But really, more bang for the buck comes from optimizing where that CPU cycle takes place and how much overhead is incurred with it. So overhead can come in many different shapes and sizes, but often, it's an opportunity cost. It's a technical debt of moving and copying data. And so really the concept of bringing compute to data is another repeated, pattern we see in organizations that are scaling AI. On another front too, like the third kind of bucket that we see there is really, builds from an understanding of what is really needed to build AI and ML solutions. Many people start with the Google 2015 paper about hidden technical debt in ML, which I think probably everybody in this call has read or is aware of. But it discusses, all the challenges of how the ML code. The ML code itself is usually just a very small amount of the hard work of the problem space, right? It's the collection and feature extraction and serving and verification and monitoring, the things that are needed for enterprise grade ML above and beyond, just a corporate hackathon, for instance. These are the hard parts, right? I like this view from Monica Rogati, a little bit different, to summarize it a slightly different way, in that the things you need to do to scale AI aren't just an unordered set, like in the Google kind of presentation of it, but is actually a hierarchy. You have to be really good at collecting data and storing and transforming. You need to be, have good people and process and technology here before you can build scale and rigor up in the top layers, right? And she presents it as a hierarchy of needs for ML. And the better you do at the bottom layers, the more time you spend, right, on the top layers, and the less fragile the whole thing becomes. So taking this as the framework, I'd suggest there's another aspect as well, kind of a platform aspect, a dimension to this, which results in creating silos, right? So if you think about the traditional data platforms that are out there today, their abilities to support these things diminish as you move up the hierarchy, right? So traditional data platforms are really, really good at collecting and moving and storing and ingesting and transforming data. And if you think about the traditional capabilities there, they start to lose efficacy as you move up the stack, right? And so data scientists are here saying, or ML engineers or ML ops engineers, or even a lot of data engineers are saying, it's great that you have all that data locked up there, but I need different languages and frameworks, right? I need lots of compute. I need different types of compute. I need extreme elasticity for the various workloads that I'm doing. And often, the traditional data platforms that are out there in data lakes are challenged in supporting those, right? And so my option is to either do nothing or to build my own kind of, my own silo, my own environment over here, where I have access to the languages and the frameworks and the processing I need. And these, and by the way, my workloads often conflict, by the way, with other users as well. All right. And so I'm going to create this other environment over here. And would you please just give me the data, right? And these platforms weren't originally built with things like governance and lineage and automation and monitoring and collaboration in mind, right? The things that have been part of the core data platform for a very long time. And many ML platforms have started building these in. There's a lot of emphasis in the ML platform world about about building these capabilities as you move down there. But even in some of the many of the partners that we work with have built out these capabilities, but even at the end of the day, you still got now multiple platforms or islands, and you have to set up this 10-kilometer long sea bridge of orchestration and things like Terraform and Airflow to weave it all together, and it all becomes a really fragile environment, right? And so actually, many of the conversations right now, in addition to fragility, are saying, what about the things that fall between the gaps, right? Things like feature stores and feature engineering is just one example of, where do we do this? Or do we do this in the data platform or the ML platform? We probably need to create something new because there's new requirements here. And really, just creating and generating a lot of technical debt and new silos, right? Many of the organizations that I work with have spent decades getting rid of all these, data silos from around their business and bringing in centralized platforms and moving to the cloud. And now they're looking upstream in the flow at even more, workloads and silos that are being created, right? And unfortunately, it's not even that simple. In reality, if you look somewhere in your organization, you'll see an architecture or a drawing that like something like this, right? Okay, maybe not exactly like this, but if you squint and blur the lines a bit, they all kind of start looking the same, right? And guys like me get paid lots of money to draw circles and lines and wire up all this complexity in order to say, yes, we have a reference architecture, a technical architecture here to help you build out these capabilities, right? But at some point, you have to really take a step back and ask, are we engineering around complexity, or are we simply complicating engineering, right? And this is not necessarily to advocate for one particular technology over another or an alternative architecture over another, but simply to bring awareness to the fact that these capability gaps create incredible technical debt within the organization. And philosophies of companies that build scale almost always center around simplicity over complexity, and really encourage that view on the world, right? When we talk about bringing data scientists and AI back to the business, it's about simplifying and reducing those silos. I was previously at Amazon, where Andy Jassy often talks about complexity is the enemy of speed and scale, right? And simplicity really is a design pattern, it's a design option that you have, an option as you're building. You have a choice. You can build better data science platforms or more capable data platforms, or you can integrate these two together. And integration is an important aspect as well. At the end of the day, the majority of the challenges and efficiencies that will be gained in AI is really down in the platform. Either your data platform enables the curation and provision of fresh features to your ML models, or it doesn't, or it hinders it, right? This is more than a technology challenge, of course. But technology certainly plays an important role in enabling an organization to bring the data scientists and the rest of the organization together. And so looking at platforms and understanding, do we really have a place where we can bring centralized people together, regardless of the workflows, regardless of the technologies? Can we support the languages and frameworks and libraries of choice with infinite scalability and capabilities? This is really getting to the point where we start talking about what is community, right? I like this 2009 paper by Peter Norvig. He talks about the unreasonable effectiveness of data. It's, I think something that most of us know kind of intuitively, that the more data you have, it has more of an outsized impact on ML capabilities. I also like the paper because of this unbelievable storm of controversy and argument that it created as well. Healthy argument, of course, whether it's true or not, but and of course, the coincidence of cloud technologies and cloud native computing platforms and open source frameworks really have created this and defined much of the last decade of AI development. Of course, like everything else in ML, there's no shortage of opinions. I think rather than focus on the differences and whether you agree with Peter Norvig's view or not, I'd propose a slightly different view. In this industry, we often talk about how data has gravity. And usually it's in reference to the engineering challenges associated with moving and storing and managing and accessing large amounts of data, right? But this isn't just a challenge. Data also has incredible power to create communities, to pull people together, to draw close all the people and groups that are dedicated to solving a particular problem or building a particular future. Data itself may or may not actually bind people together, but it certainly represents the nature of the connectedness that's at the heart of the human condition. And so bringing that philosophy, I guess you could call this a community-centric AI philosophy, something I just kind of created, but it really builds on top of it and empowers a data-centric AI philosophy as well. And this is the nature of the data cloud, by the way. And this is the mission of Snowflake, to build these capabilities which embrace that connectedness and draw people together, to pull, again, data scientists from building their own islands and building, separate technical debt across the platform, across the enterprise, to pull people together, one copy of the data, one future, one direction, one view on bringing things together. I love to see success stories like this one in particular of Pacific Life, and sure, it's nice to see success stories. We talk them all the time about some company who reduced ROI or increased ROI or reduced spending or cost on various things, or they really created some amazing ML capability that creates differentiation for them in their business. I like those stories, but also more often I really like the stories like this one, where they simply said, reducing the complexity, removing the moving parts, bringing the data science to the core platform is really what allowed us to build scale. It's not like we came up with some new cold fusion algorithm, that has changed the world. It's that we simplified and brought some simple context to the way we're doing work. And so I really like success stories like this one from Pacific Life as an example. So what does that look like, right? If you're talking about building a foundations for scalable and data-centric ML, what kind of the foundations look like? I think some of the conversations we heard earlier, was about whether it's really possible to have all of your data, whether it's even technically possible to do so. I will argue it absolutely is technically possible to do so, and you should hold your vendors accountable to be able to do that. All of your data, structured, semi-structured, unstructured, in one place, regardless of the cloud provider or the infrastructure that is running on, with the ability to scale and all the things you've expected from cloud providers, right? As far as infinite elasticity and storage and compute, et cetera. The ability to really join and build communities by bridging the gaps between organizations and the data they have. The support for pretty much any language and framework and any tooling and choice. As a design pattern, I like to tell people to as much as possible, emphasize standardization at the bottom layers of the stack and optionality at the top layers of the stack. And I think that creates an environment where we can really start building these capabilities. From the Snowflake, just if anybody's curious, if you haven't dealt with Snowflake before, this is really not meant to be a sales presentation so much as or an introduction, but just to let people know, how we are solving this problem. It's building one single cloud agnostic layer with centralized storage, decoupled compute, and all the services that are needed to wrap around that to provide a single consistent experience. And honestly, the security and governance, I loved all the discussion in the panel presentation just a minute ago about the importance of governance. That is by far the most important thing, I think, and recognizing that it's not somebody else's job. There's not a difference between AI governance and ML governance and data governance. It's all governance. The need to build different governance structures often comes from the requirement of creating silos in different architectures and trying to weave them all together. With this in mind, what we can do then is we can support all these different use cases and bring those together into one single place, which really, again, is all about reducing the technical debt, removing the barriers, removing the gaps, and really building community around the data itself. This is what I had come to present today about. I saw a couple of questions in the chat, which we'll move over to now. It's hard for me to tell from the chat which ones were from the previous panel, but I'll move through here and maybe just pick a couple of these while we're talking. Musin, maybe if I can ask you, is the desire to put questions in the chat only, or are you going to have people come off mute as well?
I appreciate, because we are busy with dividing the participants to different rooms. I appreciate if you have a look at the chat area for questions and exactly reply them, please.
Sure. Yeah.
Thanks a lot.
So I guess, one question from Donovan here. Mostly we see organizations are not so keen to change their existing complex architecture, even if they say so, but rather try to resolve the architectural challenges by building solutions around their existing architecture. So the existing complexity stays when bringing simple and slick solutions to the user, to business, as you say, is then not possible. Could you propose good practice to help sell the architectural change required? I think there's a lot to unpack in this statement. I think it's a great question. It's the right question to ask. I guess one of the design patterns I mentioned just a minute ago, which I think is really important, is emphasizing standardization at the bottom of the stack while emphasizing optionality at the top of the stack. The fact is, the top of the stack is as close as possible as you're getting to a human being, and human beings have different needs, different requirements. This is the nature of community. When you bring a community together, like we're talking about here, with different personas and different use cases in technology areas, data warehousing and database administrators, data scientists, application developers, et cetera, they all have very different needs, and exercising optionality, with the tools at the top are really important. What that means, though, is that integration becomes equally important. Because you're creating a standardization at the bottom of the stack and optionality at the top, you really need the tools and the frameworks that support a community of integrations. That's really important in there as well. I think on the other part that you mentioned here, Donovan, in this question is really about creating a need for change, or documenting an understanding of why we need to be able to change and why that's important. I actually rarely run into this personally. In many of the different organizations I've worked with, rarely run into this. I think there's an understanding of a need to change. If nothing else, I'll say that cloud computing has kind of drove a wedge through many of these conversations and said, you know, just the sheer economics is hard to argue with in any way, to where the need, right, to move on. And so a lot of organizations aren't necessarily saying, should we get rid of this complexity or not? It's really very clearly the cloud provider, cloud computing capabilities are giving us a unique opportunity to redesign, rebuild, restructure things in a way that's really going to future-proof our future direction. And then the question really becomes, what's the structure that we move from a complex kind of on-prem environment, or complex, you know, from decades of complexity from before, into and leveraging, you know, the cloud computing capabilities that are up there. So I think not sure I've answered all the question, but I think I think there's some really good points in there. And glad to any other questions in the chat as well, if anybody has any thoughts or ideas, questions, additions.